Hi everyone, we're going to talk about the calculating the formal charges today. So I have different questions for you to do with me. So bear with me and we straight away go to the problems now. Okay. So there's a nice simple formula to calculate the formal charge. It is on the screen. It is like saying Fc equal Ve minus Lp minus bond. Fc means formal charge, Ve means valence electrons, Lp means lone pair electrons, and bond means number of bonds. So now we get into the methane, first one as methane. So if we write methane, so it is gonna be like this, tetrahedral, okay, like this, and there are single bonds. So now don't worry about the hydrogen always formal charge is 0 over here in every hydrocarbon. Therefore we worry about the carbon. So carbon, group 4 of the periodic table, provide 4 valence electrons, and according to the formula you can see after valence electron there's a lone pair electrons 0 here, no lone pair electron. Then asking number of bond. So bond, there are 4 bonds, so 4 minus 4, 0. Therefore 0 charge for this molecule, or no, the 0 charge on the carbon, 0 charge. Let's move into the other one. Methanol is, I write this way, CH and OH. I write rather expanded way. Therefore oxygen has to complete the octet. Therefore 2, 4, 6, 8, because this is not the radical. Therefore we had an octet. We had to fill up the octet. So now carbon, get carbon is group 4 on the periodic table, provide pro valence electrons. And how many lone pair electrons around the carbon? 0. And how many bonds? 4. Therefore 4 minus 4, 0. Therefore 0 formal charge for carbon. Now worry about the oxygen. Oxygen groups 6 provides 6 electrons, and around that there are 4 lone pair electrons and 2 bonds. Therefore it is again 0. Therefore this oxygen has 0. Therefore this molecule has 0 charge altogether. Okay, I get the space and we move to the other one, ethane. Ethane, okay, ethane. Ethane we write like this again. Ethane C C H H H H H H. So now we worry about the carbon. These two carbon are identical. We had found that only once. We can apply the other one the same thing. So we found this carbon by the choice. So carbon group 4 on the periodic table. Therefore 4 valence electrons, and lone pair electrons around carbon 0, and how many for bonds around that? 4. Therefore 0. Therefore 0 for this carbon. So same thing for this carbon too. So we move into the ethene, and I get the space for this to write down. Okay. So now we go to the ethene, eth, eth, and hydrogens, don't worry, they got 0 formal charge always. Don't worry about the one carbon, and same to the other carbon because symmetrical. So carbon group 4 element on the periodic table is 4 provide, and lone pair electrons around carbon 0. Now how many bonds? 4. Therefore 0. So therefore 0 formal charge for this carbons, and same as this one also. And then let's move into the ethine, and I get the space before that. Ethine, okay, ethine we write uh, ethine got C H H. Okay, worry about one carbon, they all are the same. So one carbon is group 4, provide 4 valence electrons, and any lone pair electrons? No, 0. And how many bonds around that? 4. Therefore it is 0. Therefore this carbon 0. So likewise this carbon also 0. And that's it. So we move to the other slide for more complex problems. Okay, this table has 12 compounds, and we're gonna do each one one by one. So first one, boron here. Sorry, give me a second. Boron here, and it's tetrahedral. It's gonna be like this, and H. Okay. So now hydrogen, don't worry, formal charge is 0 always. We worry about the boron. So boron is group 3 atom on the element periodic table, group 3 element. Therefore it provides 3 electrons, 3 valence electrons, and number of lone pair electrons around that 0. And how many bonds? 4. Therefore there is a -1. There is a -1 charge on boron. Okay. Another one, see a methyl group. Methyl group. Therefore it is we write CH H, and also it has 2 electrons. Okay, now carbon. Worry about the carbon. Carbon group 4 on the periodic table, therefore provide 4 electrons, valence electrons, and number of lone pair electrons, there are 2 of them, and how many bonds? 3 of them. Therefore it is -1. So therefore it has -1 polarity. And we move further. So we focus on here number 5 over here, NH2. NH2. Okay, so it has 4 lone pair electrons. Okay. Now don't worry about the hydrogen, it's always 0 formal charge. So nitrogen, we worry about the nitrogen group 5 compound, therefore provide 5 electrons, and it has 4 lone pair electrons plus 2 bonds. Therefore it is -1. So this NH2 has -1 over here. And OH like that. Therefore it has 2, 4, 6, 8. So now hydrogen, don't worry about that. It has 0 formal charge for the oxygen. Oxygen group 6 provides 6 valence electrons, and around that 6 lone pair electrons, and how many bonds? 1. Therefore it has -1 charge. Therefore there is a minus over here. Okay, let's move on to the other side. This time BH3 BH3. Don't worry about the octet about this one over here, because boron is a group 3 chemical, so it satisfies with 3 bonds. So now we have to find out this one, boron is group 3 and 3 electrons and no lone pair, and how many bonds? 3. Therefore 0 polarity. And also we can get tetrahedral methane. We did this one before too, but I do it again. CH H H H. So hydrogen is always zero formal charge, so we worry about the carbon. Carbon group 4, and how many lone pair electrons? 0. How many bonds? 4. Therefore 0. Zero charge. We move to the other one. So now this one, ammonia. Ammonia is a well-known compound. It is the main component of the urea and also your urine. It is the main component. Okay, there were 2 here. So now nitrogen, confirming. Hydrogen is always zero formal charge. Nitrogen is group 5, 5 provide. And how many lone pair? 2. How many bonds? 3. Therefore 0, zero charge. And also we get water, well-known water over here. It's got octet to complete 2, 4, 5, 6, 8. So now don't worry about the hydrogen, its formal charge is 0. You worry about the oxygen. Oxygen group 6 provide lone pair electrons 4 minus bonds 2, therefore 0. So 0 charge. Okay, let's move into the other one. This time HBH. Don't worry about this octet on these ones, because you can see now you may argue that this boron has to be octet to complete and it should have lone pair, but don't worry, this look like more radicals, therefore we had to note down and copy down as it is like the same way. So it's a boron. So boron, hydrogen, don't worry about it. Boron is it's group 3 element. So group 3 lone pair electrons 0 and bond 2, therefore plus 1. There's a plus 1 charge over here. Okay, and this is also a radical. This is a radical, so don't worry about the octet over here for the carbon. So it's a radical. That's the difference over here. So maybe you think why I am not counting the octet, but it's a radical. So now we get the carbon. Carbon is group 4. How many valence electrons? 0. How many bonds? 3. Therefore 1. Therefore there's a plus 1 charge for this radical. Okay, so next move into the last. This is a tetrahedral ammonium. Ammonium also tetrahedral, well-known ion. For example, ammonium sulfate, hydrogen. So hydrogen, 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 hydrogen. So what we can do, hydrogen is always zero formal charge. Nitrogen group 5 of the periodic table, 5 electrons, minus lone pair 0 and bonds 3, bonds 3 or 2. Give me a second. 5 minus 0, and this should be 4, therefore this should be 1, therefore there's a plus 1 charge, ammonium ion. Another one, O hydrosonium ion, H, 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 and octet. So therefore oxygen, don't worry about the hydrogen, is always zero formal charge. Oxygen group 6 of the periodic table, and it had two valence electrons, so 2 minus 3 bonds, therefore 1 plus 1. There's a plus 1 charge for this hydronium ion. Okay, that's it. That's all done. Thank you very much. Good luck.